In this video, I will show you how I designed and built this robotic hand. I started off by modeling a single finger as a prototype so that I can iron out any problems. After designing it, I printed it out in PLA black using a 0.4mm nozzle. The component started to break, so I decided to print it again using PETG. Before reprinting it, I decided to increase the thickness of some of the components. I also decided to switch 0.4mm nozzle to a 0.2mm nozzle, so that the parts would come out more accurately. After printing it again, I started assembling the finger. I accidentally placed the guide that holds the wire on the wrong side of the finger, so I have to print it again.
The finger is now working, but the servo isn't turning enough, so it's not extending and retracting far all the way, so I need to fix that.
Now that I have finally finished the prototype, I can move on to making the actual hand. I started off by finding the optimal location for the servos and created a basic model of the hand. I then added holes for the screws to fit in, as well as areas where the wires are designed to fit through. I then started modeling out the fingers. For the fingers, I started off by making a basic tube, then splitting it in half and adding joints to both sides of the cylinder. After that, I added places for the rubber bands to attach to, as well as making the model more easily printable. Finally, I added a few final touches like the pulleys and sent it to the printer. After about 10 hours of printing, it was finally complete. While waiting for the rest of the components to print, I started inserting the servos. It turns out the servo I have been using to model the hand is slightly smaller than the actual servos I have.
Okay, here's a bit of an update. Managed to get all the motors to fit in. Just sanded them down a bit. I finally finished printing everything. I've labeled each servo, because each servo can only turn 180 degrees. Before putting it in, I need to angle it in the right direction, so it needs to be in the right location so that when it turns the 180 degrees, it pulls instead of pushes.
I then started attaching the strings to the pulleys.
And now I can just route the string to the finger. Okay, I just finished routing the string through the different sections. Before putting in the last pieces, I'm going to be adding rubber bands so that the fingers can return to this position after they have fully extended. Okay, I've added all of the different rubber bands, and as you can see right here, this is the mounting mechanism. The rubber band just goes in, loops around once and comes out, and this pushes it in, making it tight. All of them have now been added, and as you can see, all the fingers automatically now return to their original places once they have been moved.
I then proceeded to attaching the strings to the end of the fingers. Right after attaching each string, I ran a program that moves the servo back and forth to test the individual fingers. I have some bad news. Even though I increased the diameter of the pulleys, they still aren't big enough to fully retract the fingers. So I need to modify the servos to make them turn infinitely.
So, time to do that.
After taking the servo apart, I took note of the dimensions of the gears and modeled a new gear to convert the servo to make it turn 360 degrees. Okay, I have inserted the new modified servos.
I'm only gonna move the motor 10 degrees and I'm gonna be constantly monitoring it.
Okay, this servo looks like it can only turn in one direction, so I'm gonna have to probably take it out and manually move the potentiometer.
Okay, so now I need to test the other motors. All of the motors are now working properly. I'm gonna see if it's able to move the pinky, so... It appears that it is moving way too much.
Okay, I found out why it was not turning correctly. Basically, when I converted the servos to make them turn infinitely, the potentiometer got a bit moved, and now they're no longer accurate. So each one, I'm gonna have to find out what value I need to give it to actually stop it. To do this, I made a program that allows me to check a lot of different potential values and gives me time to visually inspect whether or not the servo is moving.
Okay, I just finished wiring everything up.
I decided to recode the entire program. Instead of the fingers moving independently, now each time the finger moves, the program prompts me, so that I can visually check that the finger has space to move. I did this because with the potentiometer bypassed, the servos are no longer precise, so they don't always return to the same position after extending and retracting, causing the finger to over-tighten, leading to the strings snapping. With both the code and the physical hand completed, it meant that I could finally start using it.